For data center construction and design, reliability isn't a feature, it's the foundation. This session delves into the architectural and engineering solutions required to achieve Tier 4 resilience and seamless interconnectivity between data centers. Experts will analyze the infrastructure challenges of reducing latency, designing for efficient power and cooling at scale, and implementing robust disaster recovery protocols. Please welcome the moderator, Aaron Chai Kao Khy, Liaison Business Development Director, MEG Consult Sdn Bhd. The other speakers are Charles Cortadas, Guasch, Partner and CEO of B Global Tech, and finally Chau Fong, Managing Director, Duriane Professionals Sdn Bhd.
Thank you to the introduction, very good introduction. So the three of us here are from the data center industry. Both of my panelists are foremost data center specialists and also designer. Maybe I start off the question to Mr. Carlos. Based on the current data center market, what are the architecture strategies key to ensuring fault tolerance and concurrent maintainability in data centers?
Okay, hello everyone. I'm Carlos. I'm the CEO of B Global Tech. We are a design consultancy firm. We are working together with all these good engineers here in Malaysia. We can say that we are almost Malaysians already. We've been here for more than 10 years. So answering your question is like, I think that there's a lot of requirements or standards that uptime itself, they are saying to like distance between mini rooms, the distance between electrical rooms. And basically, you were talking at some point about Tier 4 solutions. I think that first of all, we need to all value if a Tier 4 solution is needed or not, because we don't see it in the market. We need to solve the problems, avoid having issues there. But it's like it's Tier 4. It's something that not always is required. So this is something that we need to take in considerations. But what I will say is like in terms of, because most of the things probably you already know, it's like what we need to pay more attention is on those things that we don't see, which usually are underground utilities all around the building. We can see some crossings, either the IT deployment inside the data center. We see that there are some points that it's a single point of failure. This is in terms of architecture, what we need to look at it more. People don't pay so much attention. Usually you follow on the business solution, how you need to do the distribution of them in your room, 20 meters away, all these things. But I will recommend you, all of you, like when you look at the building, to see, try to see what you don't see on the drawings or what you don't see on surface, which is on underground utilities. Try to not have crossings, and also all the IT infrastructure inside. It's like, for example, some of the big hyperscalers, they ask at least have 9 meters, 2 routes. So at least, and avoid all these single points of failure of crossings. This will be the key point for architecture, I would say.
Oh, thank you, Mr. Carlos. Very, very in-depth solution for architecture. How about Engineer Yao? On your side, maybe you talk about mechanical, electrical. As the power density increases with AI and also high-density rack workload, what are the new cooling technologies or configuration that are proving most effective nowadays in the market?
Thank you, Aaron, for inviting me. And of course, again, we are same industry. So anyway, a very good afternoon to all. Now, of course, talking about cooling, of course, I'm an electrical engineer, but of course, in data centers industry, I also need to take care of the cooling system. Now, if you look back at 10 years ago, I think my friend here, my ex-colleague is here also, we were just talking about maybe even split unit cooling, crack units, and of course also wall-mounted cooling and all that. So that was about 10 years ago when I started DC design. Okay, I think everyone can actually also verify that. So of course, down the road, the last 10 years, the evolvement of cooling from the conventional crack units, CRA units, to the recent fan wall, and now because of the rack itself, the kilowatt that is actually the per rack kilowatt has been increased tremendously. 20, 30. Now people are also talking about to 50 kilowatts and so on. So somehow I think we have to move towards a more efficient and of course more better cooling methods, and which is why I think today, if you look around, there are also solution providers providing new technologies in cooling, including liquid cooling, and of course the latest will be also immersed cooling as well. So the scenario has changed, and designers like us have to what they call learn the new methods, cooling requirements, and of course also I think one of the important things is also the piping works, the how we actually pipe in the liquid cooling to the liquid cooling system, to the racks and so on. So a lot of integration and of course coordination needs to be done together with the server racks and so on. So it will be evolving, and in fact, I think it is very new. And for Malaysia itself, I can say that it's very new. And for us to pick up all this, we have actually to pick up new things, especially for mechanical engineers, especially on liquid cooling and also immersed cooling. So these are very new. In fact, yesterday I was in another event because it's new. Malaysia, we hope that designers hopefully don't just adopt from other countries. Perhaps also we have to learn to design these systems locally as well soon. Okay, of course now all not all are actually from maybe other parts of the world. So perhaps it's time to look at it, cooling system. And talking about cooling system is also not only the equipment itself. I think the facilities as well needs to be also strengthened because besides the cooling mechanism like liquid cooling, immersed cooling, I think the infrastructure. I think designers need to also look into, especially on the infrastructure side, like for example the cooling tower, chillers, and so on. And of course, we may be able to use not directly, of course, because our temperature is so is not conducive like Europe and all that. So maybe not because I think last time we always have to explore like whether Malaysia can do free cooling or not. But of course, not direct free cooling, but indirectly there could be some free cooling methods that could be used, especially on the infrastructure side, evaporative cooling, or even looking at increasing the temperature of the data center halls and so on. So all this, I think we should get ready ourselves and adapt ourselves, especially for mechanical engineers, to look at all these various strategies in taking care of the new cooling requirements because of the new data center racks requirement like AI racks and so on. Okay.
Carlos, you want to
Yeah,
add?
I want to add
I saw-
something. Yeah, because you said something that you were talking about. There's something new in Malaysia. There's something new in Malaysia. I would say that's something that you need to understand here. We are doing projects, let's say, around the world, and it's not new in Malaysia. You are pioneers. So it's like you're saying that, oh, maybe we don't need to copy. No, it's like you are the pioneers on these solutions. Like people is talking a lot, but you need to understand what's happening in Malaysia. It's something that it's other than the US, that maybe it's where it's original from. It's like I think that all the world will copy Malaysia. We will copy you. I hope us. But this is something that we need to take in consideration. Like don't for the first time. Yeah, I've been here for a few years, and I used to say that Malaysia was always trying to be like Singapore. It has changed. It's like I think that you Malaysians, it's like it has changed the game. If you look at the world, everybody's talking in Europe, but we cannot see any data centers. It's happening here. It will come, but they are late. So you are the pioneers. So it's like probably what will happen is that they will copy you. Of course, we need to learn. We all need to learn, but it's like I think that something that it's very important, and we see here today on all these events of W Media that plenty of people, vendors, and everything is that probably they will need to learn from all of us because I can see I'm a white monkey, but I can include it here already. So let's see how. But it's like the reality is that you are pioneers on this.
Thank you, Carlos. I think based on what you're saying that Malaysia are now the pioneering in most of what we are looking at now, the new data center market. From design's perspective, what do you think, Carlos, that is changing most rapidly? Is it the power infrastructure, cooling system, like what Engineer Yao said just now, or network connectivity?
Okay, first, I excuse myself, I'm not an IT expert, so I will say that IT is not changing much. Of course, because we were talking about speed and so on, but basically what's changing is that for the new AIs, like there will be collocation, it will always be important, the latency and so on, but what we've seen here in Malaysia is the growth of AI and let's say hyperscalers. In that case, what it's changing is not the technology, but it's changing the importance of the location. It's like we don't really need to be so near the client. We are working with hyperscalers, we are working with training AI system centers, so this is changing, but not the technology. Even if when we talk about data hall, it's changing because now we have in the same data hall, we have telco, data, and computing, so this is changing. But here, yes, I would like to have any expert on IT to come here and explain about that. But I will say that until the moment, the biggest change is in the cooling system. And it starts like with, as you were saying, like we are, in our case, we are doing a few AI projects. We have implemented the first GB200 here in Malaysia, and I would say out of the US, like for the bigger, like the a YTL project announced with NVIDIA, or the Yonder with Oracle, like they are using it. So we are implementing, they are changing from DLC, it's implementing in the rooms. We can see water on the data hall, which was something that was impossible before to see, but now it's something quite often. So it's changing a lot. And then from here, we will see another change that we are already, this is see, yes, maybe we are seeing outside of Malaysia. On the power side, we are seeing a lot of, we've been talking a lot of own power generation. But what we see, and we are doing a few projects in Spain where we will mix renewable, wind, solar, plus own generation with gas, plus the network. So here we will see, yes, a lot of changes. MEG, you will have a lot of work there where you will need to improve. It's like this is changing. It's like until now, I would say that this is something that maybe we need to improve here in Malaysia. It's like that renewable energy. It's not there. I was talking with some companies here, so I'm sure that it will grow. But this will be a point that will change the perspective on energy.
Oh, thank you, Carlos. I think, yeah, maybe Engineer Yao, like you say, as an electrical engineer, how do we future-proof the power system for the next decade? Like, for example, what Carlos was saying, we want to push more for renewable energy, but then most of the time the renewable energy is like 100 kilometers away from the one that require the source. How do you look at in an engineering perspective for us to move the power?
Now, speaking on power, as you know, a lot of people say data center actually consume a lot of power in terms of megawatt, okay, in terms of coming to gigawatt now. So of course, first, fortunately, currently we have a very stable grid TMB. Of course, you don't see much of breakdowns and all that. But of course, one day I think we also have to realize that what Carlos has mentioned, time for us to look at combination of power supply from the utility, and of course utilizing renewable energy or self-generated energy. So it could be, of course now the popular ones are solar on your roof of your data center. If you have a little bit of luxury, some may want to install ground-mounted solar to power up your data center. In fact, some of the operators are doing that. Of course, you have the land lah. So that is one of the easiest way to actually look at how we can actually utilize alternative sources. And there's could be also ways that if you are near to the sea or whatever, Malaysia a bit difficult, maybe wind and so on. But I think that is an alternative energy. And of course now there is also some other programs in Malaysia, not foolproof yet, but I think people are exploring, where solar farms are built maybe in Kedah or in Kelantan. Then your solar farms is in your data center is in Johor. So you buy power, and of course from you generate power in Kelantan, but you actually buy it from the grid. That means through the grid that is actually provided. So you have programs like CRES and so on. So of course that one is more commercial term, but I think it's doable as well as because you produce green power somewhere, then you utilize it for your data center. So these are some of the things that is actually happening in Malaysia. But moving on from there, one thing that I always maybe is not so common now is how to have a green data center. Of course, we use a lot of power, so it's time for us to also look at energy efficiency in data center. Of course, no one looks at it at this moment. We just use power because we know that we have power. So perhaps also time to look at how we can also conserve or even be more efficient in the data center. We used to think that we should have a green data center, but so far, yeah, we have, but it's not so popular at this moment. We will just use, and of course, perhaps it will be one of the things that we will need to think of in future.
Okay, so green data center wise, maybe on both for Carlos and also Engineer Yao, if the data center would like to move towards green energy, is the current infrastructure that Malaysia have, especially like just now Engineer Yao says, transmission line you buy from Kedah, but will TNB as a provider capable of, I mean, like we say solar, you have a peak power 3 to 4 p.m. But can the transmission line or the grid sustain that to sell it to Johor per se?
You are the electrical engineer. No, it's like I think that I understand the PPAs or the agreements to buy electricity, green energy away. It's like, but for me, sincerely speaking, it's like I think that it's a good way, but I think that we need to think a bit farther on that. So sorry, I'm not answering your question.
No problem.
About TMB, if they can do it, they can do it. we saw a big outage in Spain that we get a blackout because of, they said it's because of peak of renewable energy. Of course, the renewable energy there, it's a big percentage, so it was completely different. We need to be careful on that. We need to ensure that the grid is properly done. It's like, I don't know how to do it. You will help me here. But the idea is that we really need to be careful because we've seen a big outage in Spain. They said it's that because it was a peak of solar. But I don't really believe that. So it's like that there's a lot of question marks there. So I think that we should do it and we can work that. But we also need to look on, as I said, you were talking about latency. Maybe what we need to do is to bring the data centers nearby the solar farms. And this is what people are thinking now. It's like before, location was a key point to be, but now it's changing. They want power. And here, yes, I've seen that. I was saying very good things of Malaysia because I really believe that. But I think that in terms of sustainability, we're still one step below. And it's more the clients that they ask us to be super efficient on PUE and so on, which is something that they push us to be. But the tenant, they don't really need to ask for getting green energy and so on. It's like they only look at the PUE, even if they said outside that I want to be carbon neutral. When they go for colo, it's completely different approach. But it's likely some clients, they ask us to go to PUE 1.2 or 1.3, they can reduce it. But sorry, I get out of the question, but you can answer the TMB one. The difficult one, I give it to you.
Anything, Mr. Yao, the engineer Yao?
Okay, for data centers, I think just like you mentioned about the risk if let's say solar is only generating during the noon, and what happens if let's say other times and so on. So I think for data center it's a bit special because besides integrating with solar, I think one of the key things, of course, data center needs to be resilient, no downtime. So I think it's very important, besides having an alternative sources, we also have to make sure that we mitigate the risk of downtime. So how do we do that? I think a lot of things need to be done. System study needs to be done so that we are resilient. Title here, resilient. So we have to make sure that, let's say one day solar is not generating, other backup power is there. For example, genset or batteries or whatever that is actually alternative. So the designer needs to actually look at it holistically. That means not only looking at alternative sources, but also what happens if let's say there's a breakdown and a downtime.
Okay, thank you to the panelists, Engineer Yao and also Mr. Carles. That's it for our session today. Thank you, everyone.